Yep, yep.
So for last classes was more from the introduction on release engineering, what I was telling you. So getting into the subject, let's take module by module. That's what I do. So in that case, first go with the list of disciplines what we saw yesterday. So as I was saying, we have couple of modules like software configuration management, build management, continuous integration, and release management. So these are the four major subdisciplines in release engineering, and we have specific tools for each one of them, and that is what we'll be seeing. So let's take one by one and go deep into it. So to begin with, let's take the first discipline called SCM. So as the name says, software configuration management is something which the developers would start working from the time they, create the code and work. So to have a better understanding, let's go into it and see. So first we need to understand what does SCM and why do we need it. So to take the real-time scenario, as I was saying, if you take a product, there might be multiple users working on them, right? So when I say multiple users, like you two guys might be working, Prabhu and Sam. Now, given a scenario, you both can work on the same place, which means on the same region, or like one can be from PST, the other person can be from EST, or completely there might be other team who's working on India or UK, somewhere in a different time zone and region. So what will happen here is all of you would be working on a same product, okay? Wherein on a daily basis, you would be modifying certain files which you guys are responsible for. So take example, you are creating an application, like a very simple application like calculator, okay? So in that case now, say Sam is working on some future like for adding two numbers, okay, and Prabhu would be working for subtracting two numbers. So you guys take responsibility of a separate component and you will be working. So what will happen now is both of you working will be working on separate set of files, wherein the first thing is it is a bigger project wherein it's not just like one day you can finish everything. Slowly you will be doing changes on top of changes. So first day you'll come, you do some changes, and then the second day you come, you do some more changes on top of that, and it goes on until you achieve your exact goal. Now what will happen here is the first thing that is needed is you need to take a backup of each and everything, right? Because it's not an easy process to take a backup, because it sounds very easy wherein you can just copy the file name and keep. But what if you're doing a change from 1.5 months on a daily basis, and every day you're changing the content of the file many times? So are you going to take so many backups of each time you're modifying? It's not going to be a feasible solution. And the second thing, now at any given point of time, you should be able to easily identify some change which you have done. Like last week you did on some change and you are developing some future, but at the end of this week you realize that it is not going to work. So you might have to come up with a better way. So it's like rewriting everything from the beginning. So you have to know from where you had left and then proceed, right? So the changes, whatever the users would be doing, will be on top of the existing. Like if you have two lines today, tomorrow you might add another two lines on top of it, or you might remove one line and or add two more lines on top of that. So like this, changes will be on top of the changes. And that is the reason why we cannot do everything manually, because taking a backup will be a disaster, because if something goes wrong and then we cannot literally know what we did when we did, right? Now the same thing, it's not just one user, there'll be multiple users who are working on different files, different set of changes. And take from a product. Now you have been doing all the changes from your future, okay? Now suddenly when you have to give it as a product, the next thing what you should do is integrate everything in work, wherein there might be certain files which can be shared between you two. For example, now when someone has written a code, even for adding two numbers or subtracting two numbers, there are some common steps, like both of them requires at least two numbers, right? And output should be one number, something like that, wherein the exact functionality might change, but these two would be in common. So say when Sam has started writing this code first, then when Prabhu is starting later, he doesn't have to rewrite everything. So what he can do is he can use those files which will take the input of two numbers from the user to be a common one. So in that case, now if you see, the same file has been shared by both you guys. Now what will happen here is, suppose if you are doing some modification on the same file, whereas the file has been modified by one more person, then there might be some conflict. So when you take on a larger content, these kind of conflicts will occur, and it will be a huge problem when you are integrating every change and giving it as a product. Okay, so that is when, rather doing all these things manually, it's better to follow a process which release engineering gives. So that is when software configuration management, or in short SCM, is going to help. So now if you think, what is SCM? SCM is nothing but a process wherein you can keep a track of all the changes that has been gone into a product, and not only tracking it, but also having a proper control on the changes. So when I say control, we can decide who should be able to modify some file, who should not be able to modify some file, when they should be doing it. All those things we can put it as a process. So wherein the major thing is, you can, when I say track, how is that you can track something? So it is because internally it has its own database where it can store each and every change that you have done. At any given point of time, you can easily find out saying that at this date, at this time, this is the person who modified the content of a file, is what we can literally find it out. That is the power of SCM tool. Okay, so now if you go ahead and say what are the major advantages by implementing this SCM, is that it's going to help us in providing a teamwork, because it easily allows different people of the same group to know that what others have modified. Because if not, what will happen, say Prabhu would be modifying his changes at his place, and Sam would be changing all the contents at his place. So without both of them knowing that, there are some things which both will not work together, right? Whereas if you follow this SCM tool, all those things will be maintained by the SCM tool itself, or the process, wherein if, say if Sam is writing one file and the same file has been modified by Prabhu for a different reason, then clearly it will let him know that the content what you're trying to modify is quite different from what the actual file that the other person is modifying. So that it'll be easy to work as a team, and when you give us a product, you can integrate it easily. Okay, and then the important thing in you take from development of a product is finding the bugs. Because as I said, when a developer writes the code, gives it to QA or customer, and suddenly a problem occurs, we should be able to find out who created the problem. Because when you have thousands of files and each file has been modified thousands of times, you should be able to exactly find out what line of code is causing the problem. So for that, SEM will easily help us to find the defect. Because as I said, SEM is going to keep a track of each and every modification. Even if you keep a dot in a file, it will try to keep a note. Even if you rename the file, it will keep a note of that, so that you can have a complete history of whatever changes that has gone into the file. And the other thing, from a company, if you think, it will help in auditing. Because in some companies, when the client asks them, can you tell me what is the process that you're following, or there would be some standards for coding. Okay, so the companies would ask, are you following the industry standard, can you show me? So in that case, it'll be easy for you to take a complete record of all those things from this tool and give them for auditing. That is one of the other major purpose how it will be helpful. And as I said, you can always implement a proper process for it. I'm sorry. Yeah, so along with auditing, So if you take the point, you can put in a proper process and maintain who should be allowed to do the changes, who should not be allowed, when you should be able to do, how you should be doing it. All those things can be created as a process, and you can do all those things using this software configuration management. Okay, now comes the point wherein, okay, so you said that SCM is a process wherein you can do it. So how exactly these things can be achieved? Okay, so as I said, for each of this discipline, there will be corresponding tools using which we can get all these things done. Okay, so in that matter of fact, every company will use certain SCM tools through which they can achieve all this tracking and controlling the changes, whatever has been done. So in that case, for SCM to implement, there are many tools that are available in the market. So now, in that case, if you think there are tools like Subversion, ClearCase, and Perforce, and many more like CVS, Mercurial. Now the question comes is, when a company is going to choose which tool should they be using, because there is a lot of options available for the users to use different kind of tools. So it's completely debatable on one is better than other. But if you go, all this tool are going to serve the generic purpose on helping to track and controlling the changes of whatever that you do in your product. Okay, but generally you can split it into two ways. So the tools, whatever that a company is going to use, will be generally in two forms. One is open source, the other one is licensed. So when I say licensed, it is proprietary by some company wherein you have to pay for their license to work on that. Okay, so now take some companies wherein you're too much into service oriented and you don't have much time to do everything by yourself. So you can purchase the license from a particular vendor who can help you in setting up all those configurations which you need to do, and also in case if there is any problem they will be helping you to fix it. On the other way, take some crowded companies wherein they do have time for working, but they'll not be ready to put in too much of investment because you have to reduce the cost. So in that case what they can do is they can basically go for open source tools. So when I say open source, no one basically owns it. It is completely available free of cost for the users to work on, wherein we do have a separate community called open source community, in which it's been completely given for free so that anyone can go there, take the files and try to work on that. Or in case if you feel you can give your share of modifying and putting in new functionality to the existing tool, you can do. So like this, now when you take a open source tool, then it's actually available completely for free. And not only that, the problem there goes is you have to set up everything from the scratch. But it is better rather than following a standard. It is something, say that your product works in a different way, the environment is different, so you want to change everything based on that way you work in your company. So in that case people would go with open source. But the problem is the initial effort has to be put to, put in a process, and in case if there is any problem we have to solve the things by ourselves. That's the only change. So in that case, when I was talking about all these tools like Subversion, ClearCase, Perforce, we do have both. So in that way of using, currently if you see, open source tools are one of the common tools and widely used tools, because companies doesn't want to spend too much of money in buying license. And also it shouldn't be too complicated in setting everything, because when you say that, okay, let me take an open source tool like Subversion, there's a lot of effort in understanding it, installing and configuring. So and that is when they came up with a better tool called Git, which is again an open source tool and also quite lightweight, which means there is not much problem in installing and configuring, and it is very easy to get it installed and start working. So that is one of the reason why people are currently moving completely to Git. So you might be working on some other tool in the company, but on top of that, they will definitely use Git because of certain features which are not available in the other tools. Okay, so in that case, Now let's completely focus on one tool, that is Git, which will be used as a SCM tool or software configuration management tool. So before I go, is there any questions on what is SCM or why do we need it?
Yeah, I have a question, Adam. Like, I don't see like what's the benefit that people are gonna get out of open source tool? Like, if it's for free of cost and it's serving the same purpose like any other SCM. Like, I don't see. I mean, what are they gonna? I mean, what are they gonna make out of it? Like, the organization who are supporting open source tool.
Hmm.
Like you're saying, it's free of cost and everyone can make changes on it, and it's like all the organizations are going to use it. Like the people who are supporting this
Hmm.
open source tool, what are they going to make it? Like, what's the benefit?
There's no benefit. That's the point here. It's all it's a community wherein they wanted to share things. So it's not like, you're gonna get benefited out of it. It's all because of they found the problems in using this enterprise solution. So rather than paying up something huge amount, they wanted to create something for free and give it to the generic community. That's
Hmm.
the actual purpose. So there's no benefit. Only the benefit is you are going to make use of it. Right. So if you take from
And
that way, Linux is a
mhm,
completely free BSD operating system. But what people
yeah,
do that is on top of that, they take certain version and they make license. For example, Red Hat. So Red Hat is a flavor of Linux, but what they do is they got the license specifically for the kernel version that they are giving. But the same if you take CentOS, Fedora, all those things are available for free of cost. So it's not like you have to pay anything for them, right? So what is the benefit
yeah,
that you're going to get? There's nothing. It's just a community which things are formed. That is how things are moving ahead going forward.
yeah. I got it. And so when you say that everyone can make changes and everything, so this open source tool, is it just going to be into a particular organization? Let's say, let's take an organization like IBM. Like, if they're using this open source tool, and you said that people can they can make changes in it, so is it going to be only in IBM, or is it going to be only in particular product that they're going to work on, or is it going to be like people from different organizations can also work on it?
Okay, so it's going to be in two flavors. If you take any kind of open source tool, either they would be giving the complete source code of the tool so that you can create a different version out of it and start working, or you can directly get only the executable and start working. Okay, and when you're taking it, now you're just getting only the executables, wherein on top of that, if you have to write some wrapper scripts to get something done specific to your company, then those things will be not be put back into the open source community. It will be only to the company and they'll be using it within it.
Okay.
You getting the point?
Okay. Yeah, I got it. I got it.
Yeah, so it's like, let me put it very simple way. So you buy a cake, when I say
Hmm.
cake, it's just a base cake. Okay.
Hmm.
Or you take a pizza. So the
Hmm.
base layer which you're gonna use it for your crust is only thing which you get it from the open source. But on top of that, you can put anything that you want, but now only you
Oh,
know it what you're
top.
going to put. Exactly. So
Got
it's
it.
it's something like that. So each one of them
That
can
makes
take the
sense.
base, and on top of that, I want to customize whatever is that specifically. We can do
Hmm.
it only to our case. So that's how it's gonna be.
I got it. I got it. And one last question. I don't know if this makes any sense or if it might sound funny. But I'm just have this question. I got this before too. When you share files, like, are they going to make changes to the file that is shared? Or are they just going to take the copy of it and make another file and then they make the changes? Like, do you know, like, are they going to make the changes on the existing one? Or are they going to make a copy of the existing one and then they're going to make changes on it?
Uh,
Like,
it's typically how they're going to use. So it's not like it'll be the same file which you're going to directly modify. So anything that you're taking a copy to your local machine,
oh,
then you own a copy. So it's up to you whether you want to use it directly or make one more backup or copy and start
yeah,
changing things.
yeah,
And in fact,
you
that is
answered
what
my question.
we are going to do all those things because when you're downloading something from the open source, typically even they will be following a SEM tool and a process. For example, like I
Mhm.
said, you're trying to download some new application which
Yeah,
is
yeah,
available on the open source. Now, you might just think you're downloading it, but internally they will be following some SEM process
yeah.
wherein if you have to do some modification and put it back and share it with others, then you're going to use the same process here. So it's all in the back end
Right.
what it will be working.
Okay. Yeah, yeah. You answered my question. Yeah, that's clear. Thank you.
No problem. Okay, so now before we proceed, I mean, so like I was saying, all the other tools also serves the same purpose, but when specifically if you see why Git is so popular is because of these three major point. That is speed, and there is something called as branching, wherein you can do many parallel development activity. Okay, and also Git is fully distributed. So now, in order to understand what is it, uh, as I said, if you have knowledge on any other tool, then you can easily grasp it. If not, what I'll do is let me just walk you guys through some fundamentals of SEM tool. Okay, rather than just dumping onto the Git, no matter what kind of tools that you'll be working, you need to have certain understanding on the terminologies. So first, let's understand that and then keep moving forward. Okay, so now if you take it in very layman terms, as I said, SEM tool means there'll be some tool which is going to have some database internally, and that is going to keep a track of each and every change what you're going to do, right? So in that case, let's see how exactly it is going to work. So stop me in case if something is not clear. Okay, so now what will happen is, okay, let me put it so. Okay, what is this line? Okay, so what I have to assume, want you guys to assume is this is your machine on which you're working. Okay, so this is some server, separate server, which the administrators is using. Okay, now why did I come to this point? So now, when I say that you will be storing everything in some place, right? So typically, these kind of tools work in a client-server model, which means server is a place wherein you will be storing everything, and whatever that you want to access you will be using a client to work onto that. Okay, so to put it in a simple example, now you're using Facebook or Gmail. How you're accessing it? You are accessing it through the web page which acts as a client from your machine, wherein all those data, if you see where is being it's stored and parsed or maintained, whatever it does, it is doing it on a separate server. That is what the Facebook or Google is maintaining, right? So in the same case, now all this activity, whatever we'll be doing, will be majorly stored in a place called server. Okay, so when you take server, what is a server? Server is nothing but a place where you will be installing the tool, like the Git tool, and internally you will be working everything on it, right? So I'm not going into Git anymore. I'm just focusing on the general terms. So in that case, first you will have a server on which all the data would be stored and maintained. Okay, so that is what would be server. On the other side, if you take, you will be having a client on your local machine, which will be helping you to get connected with the server and work. So in that case, this will act as a server, and here this will act as a client. So now what you have to do typically is you have to install a version of client for that tool, which will help you to connect between the server. Okay, so this is how things will be working. Now, what will happen here is when you take server, the server will actually have something called as repositories in which you will be storing everything, which means now a server can be used to store many things in it, which means now in a company, there might be different products on which people might be working, correct? So now all these products, when people are working, can be stored in the same tool because you don't have to store separate tools for separate products. So now all these products are going to be maintained in the server itself. So in that case, there are nothing but a containers called repositories. Okay, so let me put it this way. Now what is this? Repositories are nothing but containers which are going to actually store all the files, all the changes, whatever the user does specific to a product. So in that case, now say that you might have a product X and a product Y. So for each of the product, you might be having a repository. So now just like that, you might have one more product Y, and for that, you will be having a repository. Okay, so what it means is repositories are containers which is going to store and maintain all the files and all the changes, whatever that you're going to do with respect to the file for a single product. Okay, so this is where exactly you store all those things and will be maintaining. Getting it? Now, for example, you're gonna have 1.java, 2.java. Okay, similarly, here you might have 1.c, 2.c. It depends on the files and what kind of product that you're using. You will be putting in all those things. Okay, so like this, you will have separate containers, and each container will be storing all the set of files corresponding to that product only. Okay, wherein if you want, you can store the same file names in other product, but still both of them are not going to be the same because this acts as a container for this product and this acts as a container for this product. So it's like on a classroom, you can have students with same name, but that doesn't mean that both of them are same, right? Because whatever names that you're going to have here is corresponding, or they're going to belong to one classroom and the other way is specific to that classroom. So in that case, server is going to contain repositories which can have many repositories, wherein each repositories are nothing but containers which is used to store files and all its changes relating to one product only. And anything that you do in this repository is known only to this repository, which means whatever files do you have in this repository, if you modify or maintain it, only this repository knows. In the same way, anything that you create here and store within this container is known only to this repository. Okay, so this is how things will be maintaining from the server. Now, when you being a user, you might have to work on certain files and a certain product, right? So first thing what you need to do is you have to decide on what is the repository on which you're going to work. So in that case, now in order to work on some particular repository on some particular files, you need a directory or a place where you can view this contents physically and you need to work. Okay, so in that case, in your client machine, okay, so we will be having something called as workspace, wherein client is nothing but just a interface between the server and the machine on which you're working. So you will have something called as workspace. So what is workspace? Workspace is a physical directory which will help you to get the contents of a particular repository for you to work. So in that case, now if you choose some content of a workspace, if you see internally, it will be actually pointing to the content of the repository. So like this, now in this workspace, you can choose which repository that you want to work, and in that repository, what are the contents or which files you want to work. Okay, wherein workspace is nothing but a directory. That's it, a physical folder in which you can see the files and modify the files. And any kind of information that you want to pass on or do some modification, it will always go between client and server. Okay, so it means like when you're creating a workspace or a directory and you want to create the files or work on this files called 1.java and 2.java, which is based on this product X repository, then you have to interact to the server using this client. That means the workspace will tell to the client saying that I want to work on this files 1.java or 2.java and I need to view this files. So client will interact with server and then server will get the details back to the client or to the workspace. So like this, anything that you are trying to do within a workspace will actually interact between client and server. Okay, so like this, you will be able to get only those files or all those files relating to a particular repository, and you will be doing some changes. So initially what a user or a developer, or it might be any kind of engineer or a QA or even a build engineer, in fact, or DevOps engineer, what they'll do is they will be maintaining a repository which will have all the files which they need. Suppose if you want to modify something, first you will create a workspace in your local machine. So once you have created, now you need to get all the files into this directory, right? So that is being told to the client, wherein the client will interact with the server and it will say that, look, this person working on this machine is trying to get a copy of the file from this repository to this workspace. So client will talk to the server and server will get back with the exact details what the workspace has asked. So in that way, you will first get the contents of the files into it, and you can continue doing changes as long as you want. And finally, when you want to store it back to the server, because you are not going to store anything in your own machine. So as soon as you have done the changes and you want to store it back to the server, once again, you inform to the client and the client will go ahead and talk to the server, and you will be updating the changes whatever you did in your local workspace to the repository. So like this, there will always be a client and server interaction that will be happening. Okay, so now what will happen here exactly in this is there are certain steps called check-in and check-out, which means now when I said that the first step called checkout. So now you have your workspace and you have some files here. So first thing is you should be able to get the files into the workspace and you should be able to modify the files, right? So for that, the step what we call it as checkout, or simply checkout is a step which will allow the user to modify a file in a workspace, wherein it will take whatever copy of the file that you want from this repository and it will put it in this directory or folder so that you can physically modify. And once you have modified the content and you want to store it back to the repository, you have to follow a process called check-in. Or check-in is nothing but a step in which the changes whatever that you have done in the workspace will be stored permanently back into the repository. Okay, so checkout means getting the copy of a file to modify, and check-in means storing it back into the repository with what you have done in your local machine in this workspace. Getting it? So now, like,
Yep.
okay, so like this, if you see, user will be doing changes and he'll be submitting it back. That means he will do a checkout and he will get a file to modify. And once he has done his changes, he will do a check-in and it will store back. So now if you think in that way, if this user modifies this file 10 times, that means are you going to take a backup of this file 10 times? No. How the SEM tool is going to work is it is going to create something called as revisions, which means now for each file, what it is going to do is it is going to create a revision. which means rather than storing the complete content of the files, it is just going to keep a reference of what and all are the changes that you have done. That means in this repository, you will not actually be having the complete content of the file, but it will be using some kind of mechanism wherein only the reference will be there, but not the physical file. So that is why if you try to go to this repository and see there, there will not be any content which is readable by human format. That means it will be using something called as references, and it will be storing it in terms of revisions. So when I say revisions, you will be having certain references in it which will be pointing to what change a user has done. So in that case, every time when you are trying to do a check-in, that is put the changes back into the repository, you will be actually storing or creating a new revision. So like this, what will happen every time a user puts back a new check-in, or if he does the check-in, then he will be creating new versions. Now, like this, every file will have multiple versions which are nothing but references to what the user has done at that particular point of time. So now using these versions, you can easily track on what time you did some modification and what are the content of this and who did it, when he did it, all those information that you want. And at the same time, when a user is requesting a file, that is when he does a checkout, what he will be doing is you will be picking up which version that you want. That means suppose if you want the latest content to modify, then you will be using the latest revision. So that when you refer to this and you say that, okay, repository, look, I want the latest content of this 1.java. That means you are actually requesting the latest reference of the revision. So from here, it will give you the content. So when you are going to get it in the workspace, only here you will be seeing the physical content. But if you go into the repository, it will be completely in the version string, wherein these things are one after the other and the changes will be on top of the other. That means when the beginning, when a Java has been created, 1.java has been created, say with 2 lines, this revision will be referring to those 2 lines. And now when you do a checkout, you add 2 more lines and you submit it back, then what will happen, or when you do a check-in, this revision will happen. And what will this revision will contain? This will contain the 2 new lines which you have modified, wherein the previous 2 lines has been referred by this. So now when you try to do a checkout from here, you will get the 2 lines which you have modified, and on top of this, this is going to happen, which means this is the first 2 lines, and top of that you have created this two. So when you do a checkout for this 1.java, you will get the complete 4 lines. So like this, every time you check out and check in, a new revision will happen. Okay, not every time for checking out. Checking out will just help you to create the physical content in the workspace, and only when you do a check-in, you will be creating a new version. And when you do a checkout, you are not actually doing the physical content of the file. It is in terms of revision, which revision you want. By default, you will always be referring to the latest revision so that you will get the latest content which is being stored in the repository. Getting it? So this is what happens every time. So they'll be generally using these terms called as checkout or check-in. So that is what will can happen. And revision is nothing but a method which the tool, SCM tool, is going to store the changes what you are trying to put back into the repository. And only through this, it will be tracking each and every change. So now if you want, you can go back saying that this could have been changed by one person, this could have been put by another person. Like that, you can easily find out who's the person who modified, what exact changes you did, when they did, and not only that, you can also keep everything simple. Rather than taking the complete backup, you can just take the reference and store it. Is that clear? Any doubt in how normal behavior of SEM works?
Yeah, Adam, I have a doubt. Like now we are creating a workspace for repositories to work on, like virtually. You can call the files from repositories, and we can work on workspace. Now my question is like, do we need to create different workspace for each repository? Like let's say that you're working on product X, and on your machine you're working on product X, and you're creating a workspace to call first Java. So you're working on it. What if you want to call a product from product Y repository, another repository? Do we have to create another workspace to call C, or can we just call uh, C from the workspace that we have already created?
Yeah, that's a good question. So now, if you typically see, as I said, a repository is going to point one product. Okay, so now if you have created a workspace and you are using it for this particular repository, obviously this workspace will be pointing only to this. Now, if you try to use the same workspace to use some other repository, then they're going to be overlap, correct? And also it is going to be confusing when you try to do some steps. So this client or the server will not know whether you are requesting something to put it into this repository or this repository. So always a workspace will be used to point only one repository, but that doesn't mean that you cannot work on two repositories at the same time. It is possible, but it's quite complicated and people won't prefer it. So given a chance, one workspace will always be pointing to one repository. So if you want to work on other repository, then you can create on different workspace in the same machine and you can work.
Yeah, so I'm just trying to comprehend what you said. Like, so yes, it is possible to work on two repositories from one workspace, but just not to make our lives complicated, we would make different workspace for different repositories, right?
Yes, what if you had the same files 1.java, 2.java name in this also?
Yeah,
Now
it's
that's
gonna be
going to be a
confusing.
complete complicator, right? That's why it's always better
Yeah.
to keep it separate.
Yes, and I also have another, like, I don't know if it's a doubt. Wait a minute. So now every time when you modify, there is a new reference that is created. So when you're calling, like let's say Java 1, the second time, okay, in the first reference you made two lines, and then in the second reference you made another two lines. When you call from workspace from product X, so you're going to get the second reference with all the four lines. So would you be able to see the changes, like on workspace? Would you be able to see the changes that are done in
Mhm.
repository, or okay,
Yes. First of all, the reference will be
okay,
on top of the previous one. So now if you point to this, this is going to contain all the changes what you did in this and this along with this.
oh, yeah, okay,
Okay, and
yeah,
now why
that's
we are doing it this way is any point of time, rather than pointing to this, if you go back here and you say point to this, then this will show the content of this and whatever is before that, that is this. So it will give you content
okay.
of both these things together.
Can we call like one particular reference? Like let's say I want to see only the. No, that doesn't make sense.
Yeah, we
Never
can
mind.
do it.
Sorry.
We can do it.
Okay.
I'll be covering all those things when we go to the scenario based. So the first thing
Yeah.
here is I just wanted to give an overview of the terminologies. So
Yeah.
that is what I want. So just me just go through quickly once again for the benefit of those
Sure.
who joined again. So generally, any kind of SCM tool that you work will be working on a client and server model where if you see you will be having a server on a different machine in which all the files whatever that you're going to store will be maintained. But if you take in that, it is not like one directory where you will be dumping everything. So server is going to have some kind of database which is going to maintain everything. So now don't think from a hard code way that if I say database, is it going to be like MySQL or Oracle database? Not exactly in that terms of database, but in a way where it stores by itself. So in that case, server is what it'll be storing everything. And in the server, you will have containers called repositories, wherein one repository points or contains a list of files and all the changes corresponding to it. So that means you can have multiple repositories in a server wherein each repository points to a product and all its files and changes related to the product. Okay, so in that way, whatever you do, modify changes and store the files in this repository is known only to this repository. Other repository doesn't know. So like that, whatever that you create, store and maintain within this repository is known only to this repository. Okay, so this is what from the server side it will be containing. And on the other side, in your local machine, whenever you want to work, you have to install something called as client, which will help to act as an interface between you and the server. Okay, so in that case, when you begin with, you will be interested to work on some repository. So say that you wanted to work on this product X. So corresponding to the product X, there will be one repository. So now when you want to work on the files related to this product X, then you need to first get the physical content of the files in your local machine, right? So how you're going to do is you have to create something called as workspace using the client. And when you create the workspace, it is nothing but a directory or a folder where you can see the content of the repositories physically. Okay, so the very first term called checkout, which means taking the particular copy of a file from the repository inside your workspace, that is where you can see the file physically, is what we call it as checkout. And once you do a checkout, you will be able to see all the files physically and you can start modifying the files. And once you have modified, the interest of us is to store back everything into the server, where if you see not in the server, inside the server corresponding to the repository, you will be storing. So that step of putting the changes back into the repository is called as check-in, wherein every time when you do a check-in, it will be creating something called as version, which is nothing but a reference of what exact change that you have done from the previous content that was stored in the repository. Getting it? So these are nothing but revisions, or simply they call it as version. So if you take SCM tool is also called as version controlling tool, because version means references or revision, where every time you do a check-in, it will be creating a reference called version or revision through which we will be able to maintain and track everything. Is that clear? It's just the
Yes,
terminology is what you should be getting it.
I get it.
Varun, Shashank, did you guys get this? Yes, Shashank. Prabhu, did you get this? Because this is quite
Yeah. I
important.
got this part.
When we go through
Yeah, I
technically
got this part.
further, you should
Mm-hmm.
be able to understand this. Okay, this is the general term. So no matter what kind of tool you work, you'll be working. Okay, so with this basic, let's move on to a particular tool like Git. Okay, so now let's go on deep into the Git and try to understand. Okay, so pretty much you should be able to see it now, right? Okay, so now don't look at anything here, just look at this particular point. So now when you see this here, as I said, whatever that I was explaining you until now is generally called as a centralized model, which means you will have a server where in the server it will contain a repository which is going to maintain all the versions of the changes whatever you're done. On the other side, there will be a client which is nothing but your local machine on which a user will be having workspace and he will be working onto this. Right, like this, there will be separate users working on their own local machine, and they will be having workspaces in that machine through which they will be able to modify. Okay, so majority of the tools like CVS, Subversion, ClearCase, Perforce, no matter whatever you name them, works in this model of centralized, wherein everything is stored in a place called server, and you work only on a copy or a physical copy in your local machine using client. Okay, now to understand why Git was introduced, let us try to see what are the problems that we might face in this. Okay, now as I was telling to you, any kind of activity that you want to do should always go through client and server interface, which means now say that you want to first create a workspace, right? All those files, whatever that you want to get a copy, has to be taken from here. Now, assume that you are going to you are going to have close to 100 GB of data in your repository. Now, if you want to create a client or a workspace in which you have to obtain 100 GB of that content of the files from the server. So now assume how much of time that it is going to take to copy 100 GB of data from the server to your local machine. Now, if you are in different region, then over the network, it is going to take a huge time, isn't it? Now, say that this is present in India or this is present in a different region, like you guys are working on Pittsburgh time or the Eastern time, the other server is present in completely in a different zone. So now, because of the latency, by the time you copy or create a workspace with that 100 GB of data from the server to your local workspace itself will take 30 to 45 minutes. Now, just to view the content of the files, you have to spend close to 30 to 45 minutes. Now, that'll be a huge time, and if you logically think, productivity will be affected a lot. And not only that, the second problem is any kind of activity that you're going to do on that 100 gig of data has to be transferred over the network, wherein your client has to interact with the server, correct? Now, as soon as you are out of the network, which means suddenly you might have to go home, or what if you have to work not just in the office, then as soon as you are outside the network, there will be no connection between the client and server. Then what will happen? You cannot do any kind of activity. So that means this kind of model will work only if you are working on a network. And not only that, time consumption is going to be lot. Okay, now these two are the problems. In addition, as I was saying, when you take a product, it is not only you, but there might be other users also working on the same product and same set of files. So now, if you want to share something with your colleague, because like I said, you can have a same common file and which is being modified by both of you. Now, if you want to tell to your buddy saying that, look, I have modified this file, the same content even you are trying to modify, why don't you take mine which is working fine? So in that case, it is not just copying from his place to your place. So in that case, you have to follow a process. Now again, for that, you have to first go to the server, store it in the repository, and then the other user has to take it from here. So like this, the normal activity wherein users can work as a team is also going to get affected because time consumption and you cannot work outside the network. Okay, so these are the problems what people are facing when they use centralized model. So now taking this particular point, how is that we can overcome using Git is what we are going to see. Okay, so now when you take Git, Git is nothing but a SEM tool, but the advantage of Git is it is not just a normal SEM tool or a normal version tool, it is a distributed version controlling tool. So what do you exactly mean by distributed version controlling system? We'll now see. Okay, so before jumping on to this, is it clear here on what is centralized model and how it is going to work from a high level? Any doubts before I proceed further?
I'm clear.
Is that clear with others?
Yes.
Okay, so now, as I said, let us see how different is Git when compared to all the other tools. So now, until now, I was saying that you need to have a separate server and a separate client, right? So the first advantage of Git is that it doesn't have a client and server. Okay, that means the question comes now. I said you need a server to store everything, and on the other way, you need a client so that you can view only whatever is needed. So rather than storing everything here, you are going to store everything in the repository, and you will be getting only the content of the files based on your need. But in Git, if I say there is no server and client, then the question comes, where is your repository that is maintained and where is your workspace going to be maintained? So for that, what you need to understand, the very first thing is there is no server and client. Okay, fine. Now, where is the repository? So that means every workspace that you create. So typically in Git, everything that you create is nothing but a workspace. Okay, and in each workspace that you create will internally contain a repository. So understand this, every workspace that you're going to create will internally contain a repository. That means you have a complete copy of the repository in the same directory where you're going to work. So now, what are the advantages of this? So the very first advantage here is speed. Now, if you think, you have a workspace in which you are able to see the files physically like what you are doing it here. And now I am saying Git also contains a repository in the same thing. Okay, now let us just take the same scenario. Here, if you see, or let me open up a new one. So now what is going to happen here is, now you are going to create a workspace in Git. So this is nothing but your workspace. Now, as I said, what is workspace? Workspace is the place where you can see the files physically, right? So in that case, what will happen? You will be able to see the files literally and work on to this. Now, along with this, in Git, what is going to happen is you will also contain the repository in it. That means along with this file, you are also going to contain this version history, so that what will happen now, rather than having a separate server, you are maintaining everything in the same workspace. That means checking in and check out will happen within this workspace. So now if you take it from this picture, what is the advantage? You don't have to interact between a separate server. Everything is going to be available in the same place, right? So whatever interaction that happens, it is going to happen only within this workspace. So obviously the actions are going to be faster, because one of the problem I said, like when you are having 100 GB of data, if you want to parse or work on that data, rather than connecting to a different server over your network, everything is present in the same directory. So things will be very fast, isn't it? Suppose if you are performing a check-in command wherein you are taking the content of the file and storing it in the repository, it is going to be super fast in Git, because the content along with the revisions are going to be present in your same directory rather than on a separate server. Okay, so that answers our first problem of speed, because every workspace is going to contain a repository by itself. Okay, now the second thing, the network issue. Now, as I said, if you want to work offline, what you can do is, here if you see, if you take this workspace along with you, it will not work, because only if you have the repository and there is a network connection between this client and server, you can do all this activity. But if you go offline, you cannot work. But here, if you take this workspace itself, the repository also is with you only. So at any point of time, you can work off outside the network also. So there are possibilities that suddenly if you're going home and you don't, you're not connected to the network, it will still work, wherein you can just work offline. So in that case, things will work better. Okay, and coming to the third thing on distributed, what do you mean? As I was saying here, suppose if you want to share some change what you have done with in your workspace with other users, first you have to check in so that it will create a new version in this repository. Then this user will do a checkout so that whatever changes that you have done will come here. So now just to share this, there has to be so much of actions and so much of network bandwidth has to be used. But the same thing that if you see here, rather than storing to a separate server from your workspace, you can directly share it with others. Wherein if you take, you are directly sharing it from your repository, not from anything else. Because here, the repository is stored in this server. First, you have to check in here and then this user has to take it. Whereas here, you can share any changes that you want directly from your workspace with one user to the other user. Okay, so that is how you can distribute. Now, if you are trying to do this way, it is quite good. But sometimes what will happen is there might be some policy threats, because if you give access to your workspace to the other user, then directly he can come here and he can modify something on your repository, and if he corrupts it, then everything will be gone for a toss. So in that case, what you can do is you can follow the same standard as you're going to use it in the central, which means you can create one more copy of your repository wherein you can use this repository or the workspace only to share changes, wherein you can use your local workspace or the local repository which is present in that to modify everything. So now when you want to share, you can directly either share it here, or if there is any policy which has to be maintained, then what you can do is you can first update the changes what you have done in your repository to the central repository, wherein you can only store and share and you cannot modify anything. Later, if some user wants to take it, they can either take it from your workspace or they can take it from the central workspace or the central repository. So that acts as a policy. So this way, Git acts as a distributed version, because in your workspace, you also have a repository. So that is the major difference of what Git is when compared to other tools. So going forward, if you see, we do not have a big headache of creating separate installation for server, separate for client, maintaining one server, maintaining client. There is nothing. Everything is just one simple workspace. So all you have to do is create one workspace, and that workspace will contain a repository. So you have the liberty of creating as many changes, modifying and storing everything with you. Wherein if you want to share this with someone else, then either you can share it directly or you can create some process wherein you can create a copy of a workspace and make it as a central workspace or central repository, where this will be used only for sharing changes and storing changes, wherein all your local copies can be used to modify the code and store the code. So you can keep storing changes in your workspace as long as you want, and when you feel that you have to share it with others, then you can share it directly or use the same concept of putting the changes to a central repository just like your centralized model, and from there others can take it. Okay, so this is what we call it as distributed version controlling system. Did you guys get that?
Yes. Yeah,
Yeah.
got it.
Shashank, Varun, did you guys get that? Shashank? Okay, so what we'll do for today is let us first understand the concepts. Okay, so from tomorrow we will get completely into practicals, because if you don't understand these concepts, getting directly into the practical will not work. So that is why we usually work in this way. So we will first understand the fundamentals, and then architecture, and then we will go inside on hands-on on the practicals. Okay, fine. So now, as I was telling you some time back, so if you take the scenario, and now when I say that in Git, each workspace is going to contain a repository. So how exactly is it going to store all the changes? So as I was saying, it will be storing it in terms of revisions, right? So in Git, we call these revisions as commit IDs, which means in Git, when you do a check-in, we refer it as commit. Okay, so specifically in Git, we use the word called commit, which means check-in. That means whatever changes that you have done in the workspace will be stored back as a revision. So how exactly Git is going to store is in terms of snapshots. Okay, so when I say that, what exactly is this reference? We should understand this in terms of snapshot. So what comes to your mind when you hear this word snapshot? Have you heard of this word snapshot anywhere before?
It's taking picture of the screen,
Yeah,
just
exactly.
capturing the screen.
Yeah, so not exactly the screen. That means it is going to take a reference what was there at that point of time, right? That is what you are trying to tell. So in the same way,
Mm-hmm.
now what will happen is when you first have some content, you will do a modification, and when you are trying to do a check-in or commit, what Git will do is it will take a snapshot. That means it will take the reference of whatever content you have in this place and what you already had here. Okay, so that will take a difference of those two, and then with respect to that, it will create a new revision wherein the revisions are referred as commit IDs. Since in Git, the check-in concept is called as commit. Every time you do a commit, the revisions, whatever that it is going to create, will be referred as commit IDs. And what are these? These are nothing but a snapshot through which it will be able to clearly say that, okay, this was the content I had earlier, and this is the content what you're trying to put it back. Okay, so that is how Git tries to create a version or commit ID. And now when you get little deeper into this commit ID, so now if you want to see what does this commit ID or the revision or version going to contain, it is going to look like this. Okay, so now in order to identify each one of them uniquely, Git will be using a value, which is nothing but it will be using a 40 long characters. So it'll be a combination of string, or it'll be a combination of digits and characters. Okay, so it is going to be a 40 long digits using which each one of them will be identified. So that means when you do a commit or a check-in, it will be creating a 40 long characters uniquely to identify this. So like this, for each time that you do a commit, there will be a 40 long characters through which you can identify this uniquely. Now, what and all does it going to contain is, it is going to contain several things. Like the first thing is a tree of objects. So when I say tree of object, first say like you are trying to do a check-in or a commit, it is going to point to the snapshot, wherein this snapshot is going to point to a previous snapshot, and this snapshot is going to point to a previous snapshot. Like this, it will be all in a linked list. Okay, so when you're actually referring to only the changes what you have done currently, it will actually help you to get back all the contents. So that is how when you're trying to see, you will be seeing all the contents. Like I said, here you might have modified one line, here two lines, here two more lines, and here two more lines. So when you're seeing it here, you will be seeing all the contents. How? Because this commit ID is going to refer to this is going to refer this, and this is going to refer this. So in that case, you will get the two lines from here, two lines from here, two lines from here, and one lines what you have modified. So that is how when you're trying to see a content of a commit ID, you'll be getting the entire content of the file through this way, wherein it will be actually a tree of snapshots. Okay, and then when it is creating a commit ID, it is not just going to create based on the content what you have. Okay, it is going to depend on various other factors. That is, who is the person who is modifying it? Okay, and along with it, if you're going to do a commit, are you going to give some kind of message to quickly identify what it is? Okay, so that is also going to be considered, and also it is going to consider on what is the timestamp on which the file has been modified. That means a commit ID is going to base all these things. That is object of or a tree of snapshot to get the complete content, and along with it, who is the person who is currently modifying it, and then what is the message that he's giving to do this check-in or commit, and along with it, what is the timestamp on which the file has been modified. So all these things together is what one single commit ID is going to be formed. Getting it? So let's not worry too much about it, but once we start creating commit IDs, you will be seeing all those things. For now, just assume this much. Every time when you do a commit, it will be creating a commit ID, which will be a 40 characters, wherein it is not just a snapshot of the data what you have put here, but it is going to be relying on certain other factors, that is who modified it, when did he modify, and what was the message that he has given. Okay, all right. Now, this is what an important thing that you need to know. So now, until now, I was telling you like how it is going to store, but now when you take what is a Git workspace going to contain. So now typically if you see, as I said, everything that you create in Git is nothing but a workspace. Okay, so in that case, what and all a Git workspace is going to contain. Okay, so when you are working on something called Git in a directory, what and all is it going to contain? So Git is mainly going to contain three areas. That means first is called as a working directory. So what is a working directory? Working directory is something through which you will be able to see the files physically. So that means when you are working on a Git workspace, you will have an area called working directory on which you will be able to see the files physically. Okay, so that means like this. This is the workspace. Here, as I said, there will be some place where you can see the contents physically. So this is nothing but working directory. Okay, now on the other side, you have a directory called Git directory, which acts as a repository and stores everything. So that is nothing but this. So in the same workspace, you will have a Git directory where it will be acting as a repository and stores all the commit IDs or versions. Okay, so these are two areas. But now in between that, we also have one more area called staging area, wherein this is a buffer place, which means a virtual place. It is not going to be physically present in your workspace. But why do we need the staging area if you think? Now, I was saying some time back, when you are trying to do a commit, that means you have modified some changes and you are trying to store it into the repository, right? Then what will happen? It will create a commit ID wherein it is going to refer to a snapshot. So how Git is going to take a snapshot? That is using this step. That means whenever you are working on Git, and if you want to put the changes or store the changes permanently, that is when you want to do a commit, then it is not a one-step place, but it has to go through two steps. That is, first, from your working directory, you will take the changes, that is the physical changes, and you will put into a place called staging area. And as soon as you put into the staging area, Git will take the snapshot. Okay, so in order to take the snapshot, you have to first do this step. And once you have put the files into the staging area, Git would have taken the snapshot. Then what you can do is you can do the commit or checking in. So then when you are going to create a commit ID, Git is going to take the reference of the snapshot, what it has created here. So that is what you need to remember in Git. That means when you want to store the changes permanently into the repository, that is when you want to do a commit, it is a two-step process wherein first you have to take the changes from your working directory and put into the staging area. And once it is done, Git will take the snapshot. And after that, you are going to do the actual check-in or commit, wherein the changes will be taken from the snapshot and stored permanently into the repository. Okay, getting this?